What up, dudes? How's it going? Algebra 1A. I'm sorry I'm late. Thank you for showing up for class. Let's go all the way up until 11:10 and we'll get this party started. I've got my whiteboard coming up and I actually figured out how to make this thing pretty awesome. It's now glow in the dark. Can you see that? Now all I gotta do is figure out how to tell the Mac I can switch the thing around or switch the video, and then I can stand on the other side like I have been. You know how I've been doing the glass thing where I've just been like talking to you and all of a sudden I start writing up over here? That's what I want to do. But for now, I basically have to turn around and write on it like it's a whiteboard. It's actually a blackboard with lights all around it. Anyway. You had no idea what this was. What are you talking about? What the piece of glass I was writing on was? And also there's this big reflection from the computer screen. I need to figure out how to get rid of that. Alright, so what we've been talking about is we've been talking about functions. I talked to you guys a little bit about the chicken katsu game that we've been playing, and I've talked to you guys a little bit about like how functions are represented using the different notation. Like for example, we had, okay, here we go. C of x, which kind of means the cost as a function of x, or I think that those examples was referring to like the cost as you rent the number of movies. So we probably should have changed that from C of x to C of m. And it just means the variable that you are using. So if we want to describe like how much money we need to set aside, the cost of money that's going to, or how much is going to cost us per month for the movies we rent, we would say, okay, well, tell me how many movies you rent and I'll tell you the cost. It depends on how many movies you rent. So this right here doesn't read C times M. This reads C of M. It's cost of M. What that means is this number, the cost, depends on this variable. Does that make sense to you? I need everyone to respond. Yes, yes, good, eesh, whatever. All right. So when you read this right here, don't think, oh, that's C times M. No, this says C of M, which means this C depends on M. It's kind of like K of M, which is, I'm going to have K represent the letter or the word katsu, and M is the meat. So over here M represents the word minutes, but over here the thing represents meat. It's kind of like saying the type of katsu you get out depends on what type of meat you put in. The meat is the variable. You can change up the meat, but you'll get different types of katsu out. Does that kind of make sense? That's in referencing back to that chicken katsu story I said. All right, good, awesome. I'm glad that this is kind of hanging with you. Let's go on to the next part. I'm going to actually start doing some of your homework for you so that way you can be, oh, Mr. Dolly is such a nice guy, and you guys won't be angry at me for being late because I apologize for being late today. By the way, I just got the schedule in yesterday, so I'm getting used to when I need to switch classes, and that's the problem that I had. I had a lot of technical difficulties this morning, and I also had this. Now, your functions don't necessarily need to be equations. They don't need to be graphs. They don't need to be words. They can be diagrams like this. So, if we take a look at this guy right here, we can figure out this is a family tree. And we can actually figure out, all right, so let's take a look at this. F means father of, if we have f of x, it means father of blank, and you fill in the blank. So if I want to do problem number 5, what is F Martha? Okay, so I guess the question I'm trying to ask is, who is the father of Martha? Yes, exactly, father of. So let's look at Martha. Who's the father of Martha? Well, the males in this case are represented in boxes. So Martha is made by James and Susan. So James is the father of Martha. So the answer to F of Martha is James. Who is the father of Martha? It's James. Does that make sense? We cool? All right. Who is the S of Susan? What S means, apparently, let's look back at our table. S means the spouse of. So it's either the husband or wife. So Susan, where's Susan? There's Susan. Oh, it's still James. Oh, okay. James is married to Susan, whose daughter was Martha. One of the daughters, at least. Does that make sense? So apparently question number 5 and question number 7 are the same answer. And this is a function, because this is what this is showing you. In fact, remember what I told you what a function is? A function is like a relationship. It relates one thing to another. And it's interesting that we're using the functions in this family tree, because this family tree is literally showing us the relationships. It's showing us how one person relates to another. All right. Let's do number 10. Who's the mother of Martha? All of these are, I don't know. Do you guys feel like you get this stuff, or is it like, can I move on? Can you guys do this on your own? Because if you guys can do it on your own, we should move on. I don't want to do the things that you find easy and then leave all the stuff that you find hard for you. All right. So this is what you have that was due today, and I'm going to tell you to turn it in tomorrow, and I'm actually doing some of your work for you. I am that nice of a teacher. All right. We covered this, right? Didn't we cover this? Yeah. We did all of this already. Okay, let's see. We didn't do this one. Yeah, we did it. We did it on Monday. You guys want to do section 1.3? It's called homework. That sounds good. Let's do homework. All right, we'll do a few of these problems over here, and then we'll do section 1.4, which is your exit pass, and then that's it. Then we'll be done. Sound good? And that will cover you guys up till Friday. All right. Section 1.3. It's like page number 10 in that little packet that I gave you. Keone makes plans to make metal bracelets for himself. Actually, let me check the calendar. Do you have to do page 11? Because that's what we're on. Or 10? Yeah, I guess you do. You got to do page all the way up to page 10. Okay, all right. So I'm going to help you out with some of your homework that's due tomorrow. Keone plans to make a metal bracelet to sell. He starts up. His startup cost is $150 to machine, or for the machine to make the bracelets. All right. So before he starts making bracelets, he's got to pay $150 for the machine. Got it. The supplies for each individual bracelet cost $2. The function rule for the situation is CB equals 150 plus 2 times B. So what this is saying here. All right. Let me just write down what this is. He said CB equals 150 plus 2B. Okay? So this is saying the cost. So I guess the question that you need to ask is, say Keone, this dude wants to make metal bracelets, right? He wants to make these little like live well bracelets that they have. And so you're one of his friends. And Keone's like, dude, can borrow money or what? So Keone's coming up to you and asking for money. He wants money. And what you say is, well, how much money do you need? Right? Yeah, Justice, you're like, no. And he's like, well, what I need is I need some money so I can start up this business of you know, making bracelets. And when I make lots of money, I'll give you your money back plus the extra money. You want to be partners in my bracelet making factory, all right? And then you say, well, how much money do you need? And he says, well, the amount of money I need depends on how many bracelets I plan to make. So that's what this is saying, is this is the cost of your startup as it depends on B. So C represents the cost of your initial investment, the amount of money that he needs to borrow from you, or the cash, I guess. And then the B represents the number of bracelets, because the amount of cash he borrows from you depends on how much bracelets he wants to make. Does that make sense? So, how much cash does he need from you? Well, if he borrows $150 from you, can he make any bracelets? Leanna says no. Raven says yes. There's a fight going on. And it looks like Justice says yes. All right? Joy says yes. Raven says yes. Gia says yes. Laura says yes. I'm so glad because only Leanna was correct. Actually, I'm not glad about that, but I'm just saying you guys are all wrong. If he borrowed $150 from you, he can't make any bracelets at all because he just bought the machine. He didn't buy the pieces of metal. Each piece of metal to make the bracelet costs $2. So you loan him $150, all he did was buy the machine. He didn't buy any pieces of stuff to make bracelets out of. Well, if he had the metal already, then he wouldn't have asked you to borrow the money. So, that's why that first $150 is there. That's the initial cost of the machine. Plus, for every bracelet you want to make, it costs $2 more. I'm explaining to you where this equation comes from. This equation is basically the equation representation of that sentence. So, well, exactly, Raven. You add $2 for every bracelet you want to make. So, you need $150. So, if you gave him $200, here's my question. If you gave him $200, how much could he make? Or maybe let's ask the question like this. Say that he only wants to make 10 bracelets. Okay? I want to make 10 bracelets. Keone's like, I want to make 10 bracelets. Metal bracelets. Alright? So what you would do is you would say, okay, now you're asking for C of 10. So this is C as a function of B, and we're leaving it open. But now if you want to talk about specific how many bracelets you want, we're plugging C of 10. So wherever you see a B in this equation, you replace with the number 10. So that becomes 150 plus 20. Why 20? Where did I get that 20 from? Exactly, Raven, you got it. 2 times 10 is 20. Yes, exactly. No, it's not 20 times 10, it's 2 times 10, because remember, it's $2 for every bracelet. So how much money is he going to ask from you to borrow if he wants to make 10 bracelets? Well, he's going to ask for $170. Okay, let's try this. What is C20? I told you what C10 is. What is C20? 190. How did you get that? You guys all got it. How did you get it? Right. Instead of adding just 20. Oh, yeah, exactly. Right there, Raven. It's 150 plus 2 times 20, which means 40. So that's 150 plus 40 is 190. Exactly. There we go. All right. So that's part A. I already did the problem for you. What is the value of C20? Well, it's 190. What does it represent in context? Well, that represents the amount of money you would need to loan Keone if he wanted to make 20 bracelets. That's what I would type in part B. Or not type, but I would write in part B. I'll write it down for you. Question 1B. The answer. The amount of money it would cost for Keone to make 20 bracelets. I wrote the total cost of making 20 bracelets. Raven, your answer is correct. My answer is correct. That's perfect. All right, so I guess from that you can answer parts A, B, C, D, E, and F because it's basically asking you the same thing. All right, let's go on to part G. If Keone only had $450 to make his first batch of bracelets, how many bracelets can he make? That's a good question. I'm going to leave that one up to you. So basically, Keone's like, hey, can borrow money or what? And you say, well, what is it for? And he's like, well, I'm going to make these bracelets. I don't mean to make him sound Hawaiian, but for some reason the name Keone makes me think Hawaiian. But anyway, all right. So you say, well, I can give you $450. Like, let's say that Keone's like your brother. So I mean, you want to hook your brother up, right? Hook a brother up. So you give him $450. How much money? How much bracelets can he make? I'll let you guys figure that out. Yeah, exactly. Ariana is already. Ariani is already on it. Yeah, yeah. Actually, you already got the answer. Arian. You already got the answer. It's Arian. Got it. It's $150 for the machine. So that leaves how much money? It leaves $300 left over. If it's $2 a pop, that's 150 bracelets you can make. Boom. Looks like Arian gave you the answer. Thank you, Arian. Everyone say thank you to Arian. Cool. Now, Raven, what you wrote down, look at that 150 plus 2 times 450. All right, Raven, what Raven wrote down, I want to take a look at that real quick. What Raven wrote down, that is, you plugged in 450 for B, didn't you? You took 450 and put it in over here, right? But that's not how you would find that. That would represent, what you did was you replaced, yeah, exactly, Raven. That's exactly my point. I want to bring it to a point because this is important stuff to talk about. If you replace this B with 450, I'll have C of 450 equals 150 plus 2 times 450. And my times, I put a dot. I can put an X if you want. That would be the cost of 450 bracelets. That's not what we're looking for. What we're looking for is the what we're looking for is if we replace CB with 450, and we're trying to figure out what B is. We replace this number with 450. Does that make sense? So we're saying the left-hand side of this equation is equal to 450. And you can logic your way. You can logic your way through it. B represents bracelets. So what this question is actually asking is a little backwards. It's saying part one, part A, B, and C, it was saying, if I told you the number of bracelets, how much would it cost? So it gives you B, asks for a cost. For part G and H, it's asking you a little backwards. It says, if I tell you the cost, I tell you this side, figure out the number of bracelets that I can make. If I give you the amount of money I can let you borrow, figure out the number of bracelets I make. So you wouldn't have the equation 150 plus 2b. Alright. If you wanted to do G the math way, because I like the way Arian did it. Arian said, alright, well, 150. The way, I'll show you kind of what she was thinking. Essentially, she kind of thought of this in her head. Okay? She said 450 equals 150 plus 2b. I basically replaced the left-hand side of the equation with 450, the number 450. We cool? So if I want to figure out what b is, I want to get B all by itself. This is where algebra comes in. You subtract 150 from both sides. You end up getting 300 equals 2B. Arian actually was thinking about this, and she didn't even think that she was thinking about this. 300 equals 2B. Got it? Then what you do is this. 2 times B, I want to get the B all by itself. I need to get rid of that 2. I'm going to divide both sides by 2. Because it's being multiplied right now, I need to undo that. So B equals 300 divided by 2, 150. You guys see how that one works? So that's what's going on. Now Erin just kind of did it in her head. She said, well, you give me $450, let's see, $150 for the machine, that leaves $300 left, $2 a pop, that's $150, whatever. But the more mathy way, the way I kind of want you, and I'm glad with that. You should be able to do that kind of stuff. But the more mathy way, the official way to kind of look at it is to look at it like this. What you're doing is you're replacing this left-hand side with the number 450, and you're solving for B. Are we cool? All right, now, Andre, what you're saying, all right, is it okay if I put C150 equals 150 plus 2 times 150? I'm not sure where you would put that. Oh, wait. Yeah, actually, Andre, you're exactly right. Because what you're saying is the cost of 150 bracelets is equal to $150 plus 2 times 150 bracelets. Let's take a look at what Andre is talking about. That first 150 represents the bracelets, whereas the second 150, the one in the middle, right after the equal sign, that represents the amount of money is invested. That's the cost of the machine. And then that last 150 represents the number of bracelets again. We cool? I hate to say this, and I know I started class late, and that is my fault, and I truly apologize for that. But classes have got to end now, and I got to start physics class up at 11:15. So I get a 5-minute break in between here. All right, I'll talk to you guys later. You guys take care, okay? I'll tell you what I'll do. I'll do another favor for you. Actually, you know what? I did you guys a good favor because I basically did section 1.3 for you, and I did 1.2 already. So, go home, work on that, turn it in through the Dropbox. All right, okay, I gotta go. Bye.